Hey, we're working the examples and finding indefinite integrals. Okay, so I'm continuing that problem set that I showed earlier. This is x times, we're going to put a parentheses here, x cubed. So this is kind of a quiz for you. You should pause the video and try to find out what this is equal to. Pause the video and get the solution, come back, and I'll have it worked out for you. All right. And if you don't want to do that, I guess just watch me work this out. So the first thing I'm going to do is rewrite. I'm going to rewrite all this. I should actually put an equal sign here instead. So this becomes x to the fourth plus 3x dx. And we'll just continue to put equal sign there. And now we can actually take the integral. And so we add 1 to the exponent, placing the exponent down below, and add 1 to the exponent, placing the exponent down below, and don't forget the plus c or it'll be wrong. Okay, so don't forget that. Alright. Oh, maybe you were working it out and now you need to see the answer. There it is. Okay. I try to work this stuff slow enough so you can work right along with me. Alright, we have 3x, and it's going to be squared times the dx here. Now, I'm going to go ahead and rewrite this. Still an equal sign because it's going to be equal. There's a couple different ways you can do this. You can go ahead and distribute that 2. So this would becomes 3 squared and then x squared, and then of course, right, all 1's over all of it. And then we can rewrite it again, and we're going to end up, now here's something actually I haven't mentioned. Let's say I have this, 3 squared is 9, right? 1/9 times 1 over x squared dx, and we have the integral sign written here. Now there's something you can do. These are some rules here. You can take this 1/9 and just bring it out front and get it out of the way, in front of the integral sign. Yes, I don't think I've mentioned that yet. Of course, we're still rewriting. Let me just go ahead and just rewrite it over here. Taking that to the top, so we have negative 2 dx. Rewrite that 1/9 times. Now we add 1. We add 1 to the exponent. Boy, I tell you, this is where confusion comes in. It's like, do we subtract 1 or add 1? We add 1. Differentiation, you subtract 1, okay? Alright, so this becomes negative 1 over negative 1 plus c. Yeah, that can get kind of confusing. Now I'm going to take the negative and just bring it out front. And of course, bringing this back down, plus c. Now remember, we can always check our work on this now. I'm going to go ahead and just rewrite this. This is negative 1 over 9x plus c. So if we were to take the derivative, let's say we were to take the derivative of this. Let's just do that. Do I have time? Maybe if I do it quickly. Okay, in other words, I'm having to rewrite this. Okay, so we're taking the derivative of this. Subtract 1 from the exponent, or no, wait a minute. Take the negative and bring it out front. Whew, it's confusing. Makes that a positive x to the negative 2. It's over 9, and of course that's 0. And that ends up being 1 over 9x squared. Right, and I believe that's what we, yeah, that's what we started with. All right.